Hello everyone, this video is all about illustrating universal set and subsets. Let us first have the idea of what is a universal set. So it is the set that contains all elements under consideration. It is also denoted by capital letter U. Now, let us have an example of universal set. Let's say U, wherein it contains elements A, E, I, O, and then U. Now, let's say I want another set, and let us name it as set A. So, set A contains elements A and then E. Now, set A contains elements or letters A and then E of set U, right? So here we can say that set A is a subset of U. Okay? So when we say subset, or we have proper subset, these are the set wherein the elements are from the universal set. So in symbol here, okay, set A is a proper. Okay, later on I'm going to tell you the difference between subset and then proper. So A is a proper subset of U. Okay, A is a proper subset of U. So we read it as A is a proper subset of U. Okay. Now, another set. Let's say we have set B. Okay. So wherein it contains I and then O. So this is another subset of U. And then since that elements B are also elements in U, so we can say that B is a proper subset of U. So B is a proper subset of U. Okay. So also we can say that set A and then set B, this one, set A and then set B are equivalent sets. When we say equivalent sets, so these are the sets that have different elements but have the same amount of elements. So let us remember the cardinality of the set, wherein here the cardinality of set U, okay, and of U is equal to 1, 2, 3, 4, 5. So we have 5. Then here, the cardinality of set A is 2, right? And then here, the cardinality of set B is 2 also. So we call that as equivalent sets. So set A and then set B are what we call the equivalent sets. Now, let us have another set. Let's say we have set C. Okay? wherein it contains E and then A. So, even though they are not the same order of set A, this one, as you can see, they have the same element, right? So, though they are not of the same order, but they have the same elements. We have A and then E, we have E and then A, right? Okay, so we can say that they are what we call equal sets. Okay, so they are what we call equal sets. When we say equal sets, these are elements that have the same elements. Okay, so A and B are what we call equal sets. They are also equivalent sets because they have the same number of elements. So as you can see, the cardinality of set C is 2. Okay, so going back to set A and then set B, they are what we call equivalent sets, but they are not equal sets because they have different elements, right? So B and then C also are what we called equivalent sets, for they have the same they have the same amount of elements. Okay, let us have another set. Let's say we have, let B equals to 1, 3, 5, 7, and 9. Okay, then we have another set A, that contains elements 1, 5, and then 9. So notice that 1, 5, and then 9 are elements in set A, but also elements in set B, right? So we can say that A is a proper subset of B. So that is in symbol, and then we read that as A is a proper subset of B. Okay, and then let us have another one. Let B equals to 1, 3, 5, 7, and 9. And then we have another set that contains 1, 3, 5, 7, and then 9. So A is a subset of B. Okay, so in symbol, A, this one, is a subset of B. So it looks like equal sign at the lower part. So here, we read this as A is a subset of B. Okay, so that is in symbol. So as you can see, the elements of A and the elements of B are equally the same. Okay, so in symbol, okay, this one, we read this as is a proper subset of, and then this symbol with equal sign at the lower part is a subset. Okay, subset of, and then this one, this symbol, we read this as not a proper subset of. Okay, let us have an example. let's say we have set M, wherein it contains elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have set P, containing elements 1, 3, 5, 7, and 9. We have set A, wherein the elements are 2, 4, 6, 8, and then 10. We have an empty set, which is set N, and then T, the element is 0, and then element E, we have, set E, wherein elements are 3, 1, 7, 9, and then 5. So tell whether the following statement is true or false. So number 1, set M is a universal set. So this is true. Okay, so we have a true statement. So M contains all the elements of the other sets. That's why this set M is what we call the universal set. So number 2, A is a proper subset of M. So A is a proper subset of M. Yes, this is true. Okay, why? Because all elements of A are in elements of M. Next, number 3, E is a subset of P. So as you can see, they have the same elements and cardinality of sets, or the number of elements. So this is true. Okay, next, number 4. So N is a proper subset of M. Okay, so the answer here is true. So empty set is a proper subset of any set. Next, number 5, M is a proper subset of P. So here, this is false. Why? Because M is not a proper subset of P. Remember that M is a universal set. Okay? And this statement is false. Next, number 6, A and then P are equal sets. So here the answer is false. Why? Because they are, instead of they are equal sets, we call them as they are what we call equivalent sets because of their equal number of elements. Number 7, T is a proper subset of M. So the answer here is false. Okay, since 0 is not an element of M, so T is a subset of M. Next, that is false. Next, number 8, A is a subset of P. So here, as you can see, this is a false. Okay, this is a false statement. Okay, so we're done with our topic about universal sets and universal set and subsets. I hope that you learned how to illustrate universal sets and then subsets. So thank you very much for watching the video. Don't forget to like, comment, and then share this video, and then click the notification button for more videos and updates. Thank you.